There we go.
There you go.
All right, we are going to go ahead and get started. Thank you for joining us for this month's From the Field Farm Chat. We are joined today by a team of researchers from Utah State University who are researching nitrogen management in dryland wheat. And that is a research project that is funded in part by Idaho grower dollars. So Earl Creech from Utah State is heading that up. And I'm just going to go ahead and let you introduce yourself, Earl, and introduce the other people on your team.
Thanks, Brittany. So yeah, I'm Earl Creech. I'm the extension agronomist at Utah State University. And I grew up on a farm in Utah, actually right on the Utah-Idaho border. My folks own about a mile of the border, but it's all on the Utah side. So we're really close to Idaho, but we're not quite there. We didn't quite have the muster to get across the border. But I deal with all crops in Utah as the extension agronomist. So I deal with everything from the forages to the small grains to corn, oil seeds, and irrigated and dryland. And there's we do a lot of work with Southeast Idaho growers. So this project was just kind of a natural fit to kind of look at some of the fertility issues that these growers are facing. So with me, I've got Grant Carden, and Grant is the extension soil specialist at Utah State, and he has just a lot of knowledge on nitrogen and soils in this environment. So I thought it would be helpful to have him on here. Brad Davis is the graduate student that does all the day-to-day work on this project. Brad's is doing a PhD. He's from most recently from the University of Georgia, but grew up in Tennessee but did his bachelor's degree at BYU Idaho up in Rexburg. And then I see also Sarah, you joined us. Sarah from the University of Idaho is handling the wheat quality aspects of this project. So that's kind of us.
Great, thank you. For all of you who are joining us, I want to encourage you to ask questions. Jim Peterson, the Idaho Wheat Commission research consultant, and I will ask questions, but please feel free to unmute your microphone. You can type a question into the chat and we will get that asked for you, or you can use the icons at the bottom of your screen under reactions to raise your hand also if you have a question, and we can make sure it gets asked. So I'll start a little bit, and this is kind of by way of introductions, Earl, also. But if you could just give us an overview of this project with nitrogen management in dryland winter wheat, specifically in southeastern Idaho. And then how far are you into the project? What are your goals, I guess, overall? And have you found anything unexpected so far?
Well, so this project is, I guess the idea behind this project is one of the major inputs in dryland wheat is nitrogen fertilizer. And we know, so it's expensive, it's something that we know we have to do. But there's been a lot of change in the wheat industry since the current management recommendation, nitrogen management recommendations came to be. So most of the recommendations that we're using today in dryland wheat in this area are from the 50s, the 60s, the 70s. And when you start to think about the amount of change that has occurred in the varieties that we use, the technologies that have changed in terms of how we grow things, the nitrogen sources that are available, it just makes sense to occasionally go back and look at what we do and how we're doing it, and just try to see if there's maybe a better way to deal with nitrogen in today's world. So we've got trials on 4 farms. We've got a whole pile of treatments, different nitrogen sources, different polymer coatings, different inhibitors. We've got just all sorts of treatments and rates and timings that we're looking at. And maybe I'll just turn the time to Brad Davis to just give us a real quick rundown of just some key findings so far. Oh, we're currently in year 1. We just finished the first year. We're just finishing the first year, so we haven't even done the quality analysis on the crops that we've harvested. But year 1 of 3. So these are very preliminary, and hopefully the years 2 and 3 will really be able to zero in on exactly where we need to be in terms of rates and products that we're using. So Brad.
Hi everyone. So I'm just going to give you a quick overview of what we found. As far as if we've seen any benefit from the efficiency technologies like polymer coated urea or denitrifiers or volatilization inhibitors, we have seen some positive effect from each of those at different timings. And as far as timing goes, we found that fall is the least beneficial time to apply your nitrogen, and that spring seems to be the most beneficial. As far as split timings go, there was really no difference between the split timings and a full rate of N when compared to the efficiency products. But if you are going to apply a split application, it shows that if you apply in the late fall, if you apply a fall, there's really no benefit from that timing. But if you apply a fall, early spring, you'll get more benefit from a fuller rate in the early spring than in late spring. And late spring would be around heading. That's all I have there.
How much of a difference do you see between spring and fall application?
So for the efficiency products, you see 5 bushel an acre, but between, say, if you look at spring for ammonium nitrate and compare that to Super U, you see a 8 bushel an acre difference. Yeah.
So that's pretty significant.
Yeah.
Out of how much? A difference. What's the base for the ammonia?
Oh, so what's the bushel per acre that they're seeing?
Yeah.
So
okay.
base. Okay. So Super U was 47 bushel an acre, and ammonium nitrate was 40, and then ESN was 37. So and all those were in the spring. And when you look at the fall, Super U was 42, and ammonium nitrate was similar to what it was in the spring.
Yeah. So roughly 20% increase with the protected forms applied in the spring versus the fall application of the unprotected form.
Yes, sir.
Yeah. Which it's not trivial.
Right.
That's you run all the statistics on that. I think that's important to note. So
and Brad, maybe could you mention what farms we have these trials on?
So we have one at the USU farm in Blue Creek, and then we have one with Scott Furman in Pocatello Valley, one in Rockland with Corey Crest, as I see here, and then one in Preston with Robert Swainson. So four locations that are pretty spread out in area as far as southern Idaho goes.
So could you guys, for the benefit of a poor plant breeder here, explain a little bit more about the nitrogen technologies that are coming online and what growers ought to be looking for the different forms of nitrogen that are available now?
Well, maybe I can comment a little bit about that. You know, we've always relied on ammonium nitrate, urea in many cases, ammonium sulfate in some areas and things like that is kind of our standards. More and more, we're getting a shift to more multi-nutrient kind of ammoniated phosphates with a little bit of sulfur and other things mixed in with them and stuff like that. So we're typically pretty confident in the chemistry background that we have with the way that these different traditional forms work. The question always comes, well, when we add other things in, do we get any kind of synergistic effect or additive effect or anything like that? And for the most part, when we're dealing with just initial nutrient deficiencies and supplying it with, you know, these different chemistries, the past information pretty much holds with respect to performance. It's when we start looking at these specialty formulations where we have some protective element associated with the technology, say like the polymer coating on the urea with the ESN material out of Nutrient, or the Super U that Brad mentioned. That's it's got a combination of urease inhibitor and nitrification inhibitors mixed with it. So when we start looking at protecting potential changes in the chemistry, and that's the biggest issue there, then we are seeing some real benefit in some of those technologies in certain situations. Brad mentioned that with the protected forms, those that have these inhibitors or additives that change the way the chemistry happens with the transformation of nitrogen, then, you know, with a spring application versus, say, a fall application of our traditional forms, we get that 20 to 25% increase in performance. Is that worth the addition of the technology? That's the other thing that comes into play. Well, you know, those are more expensive materials. Yeah, we can get a yield increase, potentially a quality increase as we look at what Sarah ends up coming up with on these. But, you know, does that pan out to an economic benefit? And that's going to be the big question in the end. But I think it's important that we go back and periodically ground truth or re-anchor ourselves to new formulations as they come out, because as Earl mentioned, you know, we can say we understand the chemistry of individual elements, which we do, but where we have big changes in technology where we can alter the actual chemistry, then we really need to start taking a look at it. And that's where these inhibitors and the coatings and other things come into play, because they alter the transformation of nitrogen, preventing the forms that are going to be more easily lost, either to volatilization or to denitrification or to leaching losses over the course of the season. So, yeah, I think it's interesting that as we see them come out, you know, they're promoted ahead of the testing oftentimes, and we have a hard time catching up with the sales side of things when it comes to various new forms. So, you know, if there's ever anything that you guys are really interested in us taking a look at when it comes to something that's being heavily promoted in an area, then we want to know about it, because those are the kinds of things we can mobilize to address. But in this case, we're looking at, you know, really materials that have kind of come to the forefront as being protective of nitrogen loss, and that's why we wanted to incorporate them in this particular study. So
this is a way you can kind of tie in what was done in the past, and so what's already been done is not irrelevant necessarily.
Oh, yeah.
So it's a way to extend it into new products as well as build on an old information base is the idea.
So when we see a new technology come out that has a reasonable expectation of altering maybe some of the base chemistry that we understand, that's where we really need to take and do the observation. Other than that, you know, if a formulation comes out that really doesn't address changes or transformations in the chemistry, then we can pretty much rely just in terms of what the performance is going to be. But yeah, and that's why we're constantly evaluating it. And it's sometimes when people get the impression that maybe we're poo-pooing a particular kind of product because we don't think it's going to be an enhancement over traditional forms. And it's because we're more confident in the fact that the chemistry isn't being altered of the transformation of those elements. But, you know, we do need to look at them, especially if they're getting heavily promoted in a certain area. Corey had a question. I think he raised his hand just a minute ago.
Yeah, I guess a couple things. All these were top dress, correct? Just put on top of the ground.
That's
Yeah.
right.
Was there any
And-
incorporation at all on these? I don't remember.
No, sir.
No, okay.
I'll kind of relate some of my own experience, and you know, the amount of moisture is always tough to foretell. But in dry land, a lot of times what seems to work for me is you got to get that nitrogen deep into the soil profile come reproductive time, and that's, you know, mid-May to end of June around here, depending on what crops. And a lot of times that's when you're running short of soil moisture on dry land. So that plant's pulling from that 2 and 3 foot level a lot of times. And to me, that's where the nitrogen needs to be. And so a lot of the questions I have is, you know, late fall, early spring seems to be pretty similar to me. I can't really see much difference, but you know, how those coated products break down and timing release of those is so much a black hole for me. You know, on dry land, I'm afraid to use those just because I don't know when that's actually going to break down and start moving through the profile and come available. And the other tough thing for me is on dry land is 5 more units of nitrogen. It's going to be the same cost per acre as that ESN or fancy Super U or some fancy product going to have the end result. So that's kind of some of the stuff I'd like to, you know, see tested. And I know those are hard to prove when you're working with such small increments and amounts. But anyway, those are some thoughts I had.
Yeah. Well, those are some good questions to be investigating as we go along with this. Especially the economics. I think the economics is going to be interesting to take a look at in this. But 20% increase, is that going to be worth, what you're talking about, that extra technology or not?
Is that going to be worth the extra 500 tons or $500 a ton? You know, I don't know yet.
Yeah.
So we had a question in the chat. Are the varieties the same over the 4 locations of test plots?
You want me to take that one, Irv?
Yeah.
So they are not. We decided to just use whatever variety the farmers were using. That way they could use the results that we get on the varieties that they're growing. And the varieties that they're using, there's 2 farmers that are actually using the same variety, and that's Curlew. And then Promontory and was it Mela? M-E-L-A, however you say that, CL,
Me,
out of Washington. Is that right, Corey?
yeah, Mila. That was actually on my neighbor's field last year, but yeah, it was Mila, and that's what I was going to kind of ask him what his yield was alongside those, if that relates to it.
And that's all the varieties that we use. And that's 3 hard reds and 1 soft white.
Soft
variety.
white.
Yeah.
As far as Sarah's concerned, there's a big difference too in quality, what I consider quality of soft white and quality of hard red with response to nitrogen use. That's tough to merge those 2 together, but I guess we can see what we figure.
I was planning on not putting those together because we'll have 2 years of soft white with yours. Okay. So we'll kind of have, and that might end up being a good thing to have a soft white and then a hard red and kind of have both of them to look at for growers.
So
So-
this is-
Just so, oh,
well, go ahead, please.
go
ahead,
I was
Corey.
gonna ask just for my own information to try and relate this a little better. What were the rates you guys put on relative to those yields? And yeah, a huge thing for me is my protein level relative to my yield, relative to the amount of nitrogen I put on. That's for me so key in determining whether I got good use efficiency. I put on too much, I didn't put on enough, and those sort of things.
Yeah, Brad, you want to
So,
take that?
yeah, so the rates that we used was 50 pounds an acre at 100%. And then 75% of that, which is around 40, it's actually 37.5. And then 50% rate, which is 25 pounds of N per acre. And then all the splits were done at the 50 pounds per acre.
And you had some splits that were 1/3 fall, early spring, late spring, 1/3, 2/3 fall, late spring.
Yeah.
I mean, there was
One
some
half, one
differences in
half.
some of the timings, right? Yeah.
Yeah.
If
And we
you are
did do it.
using- Oh, sorry, go ahead.
No, go ahead. Go ahead. It's okay.
If you are using different varieties and different classes for these trials, how long is a reasonable amount of time before you have really solid results? I mean, is 3 years adequate? Will you need to, do you foresee this research lasting beyond the 3 years so that you can have consistent results across all of the variables?
Well, that depends, because so much of nitrogen response is dependent on the weather. And so as long as we can see wet conditions, dry conditions, high temps, low temps, just kind of a range of conditions where we feel like we've really captured what can happen, then we start feeling really good. If we do this for 3 years and every year's dry and cold or dry and hot or whatever, and they're all the same, and then the results jive, then maybe you start thinking that, boy, we really need to see some of these other environmental conditions that we can get. So that's the hope, is that by doing it over years, that you see some of those different environmental conditions to see if the response is the same, or if we have to have different recommendations for the different environmental conditions that you might see, and the different weather conditions that we could see.
I assume there's other people around the country doing similar things that you also can use their research to confirm or not what you're seeing and make sense, right? Is there something special or unique about the Southern Idaho soils that makes some of that work less relevant?
Grant, you want to take that?
Well, yes and no. I'll give you the professor answer. It depends, right?
Okay, fair enough.
Yeah, Intermountain West soils are fairly unique in the sense that you've got colder, drier, typically conditions, higher pH, salinity potentially in soils here than you would say in Montana, where they're producing wheat on different kinds of soils, but still within quote unquote the West or whatever. So, or even in California, et cetera. So yes, the research going on in a lot of different areas. And so you want to try to glean from it as much of an apples to apples type comparison as you can. And sometimes what we can do is we can say, you anchor it to a certain level of precipitation, or you anchor it to certain soil conditions or things, and you can kind of tease out these differences and categorize them, and then do the analysis based on more of a categorical kind of test rather than lumping them all together. So yeah, wherever we can compare and contrast our results to our neighboring states, the better, and glean from their ideas. There was a question, I think, that was posed, based on what you do, are you going to tweak your treatment somewhere down the line to address some of these questions that are coming in. And, to really be effective, to get back to Brittany's question, to be really effective, you've got to maintain consistency in the treatments year in, year out. Otherwise, you lose control of all those extraneous variables that are going to be going, helter skelter sometimes. We want to keep everything as constant as possible through the course of the study. And then if that raises additional questions to change, you change in the next round kind of thing, rather than year to year within the same study. So that helps us then be able to take our data and categorize it against others that we might see in other states. I hope that kind of at least addresses the question, Jim, a little bit.
Yeah, no, that's fair enough. I mean, I realize how difficult it is to do dryland research.
Yeah.
There are years where all you want to do is tear out your hair and throw all the data away.
Yeah.
And trying to keep that in perspective, what's realistic, what's representative, and what's not is pretty tough sometimes. And trying to find data that can help support your conclusions from other areas, sometimes relevant, sometimes is not. But I appreciate the challenges you guys go through in this, and it is tough to know how many years is it going to take, how many treatments does it take, how many soil types you need to be on to develop a robust recommendations for the growers.
Yeah. And of course, Jim, based on my hairdo, you can see I've done a lot of research on dryland.
Fair enough.
Yeah. It seems to be kind of a thread through all three of us here, right?
Yeah.
Sarah's doing better in the hair category than the rest of us, but
Fair enough.
I want to go back and maybe address something that Corey mentioned on the protein and the importance of that. I did a lot of work. I was at Colorado State University as well for part of my career. And one of the things we came across all the time was the idea that if you wanted to get the yield, the nitrogen needed to be there in case you got the water. But then if you started to promote good biomass growth because you did get the water, would that end up causing kind of biomass dilution of your eventual protein? And then once you got to a certain level of yield, then the protein would kind of recover back in the grain. And then that was in a really optimum condition. So it was always kind of a little roulette game. Do I put enough nitrogen into the system so that I can take advantage of moisture when it is there? But then am I going to push it to the point where I dilute out in the grain what my protein content, and then get a hit with the premiums that I might otherwise have? So it really is quite a complicated process in these small grains. So we're hoping to get by staying consistent with our treatments to get as much of the information on the yield and quality as we can with these particular treatments, and then enhance that with maybe additional timings or across longer periods of time where we can capture some of that variability and moisture a little bit better.
Since you mentioned, just one last question from my side. Mentioned quality. What do you hope to see on quality other than just the protein reaction, other than protein response to the different treatments?
Well,
what's Sarah planning on measuring on all these? Not just protein, I'm assuming. Are we baking out and things like that with these, making flowers on them and that kind of stuff?
Yeah, Sarah, you want to chime in?
Yeah, sure. So what we typically do is we'll hand out a checklist, and the researcher will usually ask us to do whatever they want. All of the samples that you're sending are hards, correct? Or is it the mix? I can't remember which one that we determined. Are they softs and hards?
Brad,
We haven't really nailed down which ones we're going to send yet.
Okay.
That's the reason why go ahead.
Depending upon what they are, we do both. We'll mill them down to their flour and we'll analyze the flour. We've got a new NIR machine. So other than ash, protein, and moisture, we also can measure fiber, fat, and starch content. So which, hey, it's interesting. Don't know what you're going to use it for, but sure, let's have the data. It's something at least. So that's actually the response that I've been getting a lot from the researchers that we're collaborating with. They're like, what are we using it for? And I'm like, I don't know. That's up to you. It's something, it's a new parameter. Use it. So, but we can then take, and with the hards, we'll do mixographs to determine whether it's even worth baking. That way we can know how much water to put in with the dough for the actual bake. We'll bake out the bread. I will do an external and internal analysis, give it, a number between 1 and 9, I think it is. And I'll give also comments like, okay, this one was a 2 and this one was a 2, but this one looked a little bit better because it had a better color, for example. Do kind of the same thing with cookies and softs. So softs don't have any pre-tests before they're baked into cookies. They're just using the moisture that we get from the flour. We bake it into a cookie and we'll give a top grade and a diameter. And that generally gives an idea of how well the soft is going to bake into a cookie. If you want additional tests, we'll do SRCs, which is the solvent retention capacity. And that tells you like quantity of your glutens, the quality of your proteins, I guess. And that's generally done on softs only, but there's more people requesting it for hards. Specifically, Jared Spackman is requesting that we do both his hards and softs for his fertilizer nitrogen trials. So some people are requesting it more often. It really depends upon what you want to do. We also do noodles for softs. It's not a great idea to do noodles for hards, and especially not a great idea to do noodles for hard reds, because what we're looking for is color. And if you kind of start out with a hard red, your color's off anyway from what they really want you to do. So if you really want your soft whites baked into or created a noodle out of it, and we could give you the noodle color spectrum. So that way you can look at the Asian market quantities, quality parameters for Asian noodles. So it really depends upon what you want.
Yeah, thanks, Sarah. And I think from the standpoint of what we're doing, we want to get as much quality data as we can, and so that we can run the stats on it and see if these different nitrogen fertilization programs and products had any effect on any of those. If they don't have an effect, then we know. And if they do, we know, and we may have to make adjustments in how we fertilize this crop to meet whatever quality parameter we're trying to hit.
The easiest and quickest way to know is a bake. So any other tests are just details.
I have another quick comment. Okay, I think I'm working. I just texted the guy whose field that was in. He's up hunting somewhere and can't be on the Zoom, but he said his yield right around the plots was only 37. And I kind of know what he put on fertilizer. So, and he also said he flew over him a couple times in his little hang glider thingamabob. So he said there was definite differences you could see from the air. So breaking those out side by side, or at least the soft versus the hard wheats, might be beneficial for us, as well as kind of comparing that to the standard check next to the plots. So like I say, I don't know the data for that. You kind of gave them all overall, but that might be one thing that's.
You said his was around 30?
37 is what he just texted me, which that surprised me. That was.
So in your plot, we saw for no application, we saw around 21. And then for the efficiency products, we saw around 40. So, and that was both fall, for spring, we saw 39. And then for fall, we saw around 32 and 33.
For the full laps.
Yes, for 50 pounds an acre. And then for fall and AN, it was 34 and 37. 34 for fall and 37 for spring for ammonium nitrate. Sorry, I didn't complete my thought or sentence.
So that's pretty consistent with what you saw, that the protected products in the spring were better than the standard products in the fall.
That's right.
The big separation. And
Yeah.
fall was always less effective than the spring application, regardless.
Yes, regardless.
And Corey, we'll definitely be presenting, we'll definitely have all of these broken out by site. Statistically, we sometimes we run some tests to see if we can combine locations if the response was similar, and that gives us a little bit more power statistically to make more broad recommendations. But as a baseline, we'd definitely be presenting them, as individual sites.
I'm asking a lot, and I apologize for this, but this is kind of near and dear to my area. But the other thing that would be helpful is weather data. Timing of a rainfall event after the applications to me is very important. And then the amount of total rain, well, I think is less important. I've become convinced I can't wash nitrogen out of my soils. I know you university types might disagree, but if I have a hole from a crop failure in a certain spot, I can have a fallow year afterwards and then 2 winters of snowfall on it and everything, and I still see a huge yield bump where that hole was from no nitrogen uptake from the previous crop, 2.5 years later. I don't know. I'd like some studies done on that, because part of me is just saying, let's dump it all on in the fall or put it all in with the drill and the mid-row banders and not risk losing for volatilization, because I think that's a real thing for my area and my pH, a whole lot more so than leaching. So
Yeah.
I'm just kind of thinking out loud here, throwing stuff out, but this is a lot of stuff I've kind of found over the years and thought about from my own experience. And I'm not sure how to relate that to research, but
Well, I would say you're spot on in terms of worrying about leaching, and particularly in dryland conditions. We just don't have the moisture regime to really push that. But the volatilization issues with all of these forms left on the surface, that's tough. That's the biggest potential loss there. And that's where these protected, polymer coatings and the urease inhibitors, nitrification inhibitors really come into play on altering the chemistry. So I'd like to explore with somebody eventually one of these times, and we can talk about it with Earl, is getting that down deeper. I mean, with anhydrous, we were able to get it a little deeper than we can with some of these solids, but that's not really our opportunity anymore.
Well, I think it is. I mean, depending on how both of my drills are set up with mid-row banders. I can put gobs of nitrogen 6 inches away from the seed, 4 inches deep. And that's what I do with all my spring crops right now. I put my full everything on in the mid-row banders with some starter with the seed. And I'm close to doing that in the fall with my fall wheat or early spring, other than I like liquid. I can variable rate it very easily is my reason I stick with liquid top dress. But I just kind of start to wonder, especially $6 diesel makes you rethink a lot of things, and less passes might be better for us dryland guys.
Yeah.
So I appreciate all of your questions, Corey, and it kind of leads into, unfortunately, we are kind of at our time limit and need to sort of wrap up. So I guess I just want to ask 2 main questions. Well, first of all, did you learn anything in year 1 that will change plans for year 2 and 3 as far as your research? And then the second question, it has 2 parts, and it's what do you hope this research translates into economic benefits and returns for growers? And what's your timeline for getting that information out for growers in the future?
So in terms of lessons learned, and did that impact anything going from one year to the next? I think Grant explained that earlier, how it's really important for us to keep the same treatment structure from year to year while we get this particular project through. That way we have that continuity, and we can really get some answers. So no, we haven't really changed anything related to how we're doing the work. We actually found, I mean, we had a great experience with the farmer cooperators we worked with. Usually we can count on losing a location or two as a result of somebody making a mistake and oops, and either harvesting your plots or fertilizing them or doing something to complicate things, but every trial went through without a hitch. So it was really good. Question 2 was what? Sorry, Brittany.
How long is it going to take to get effective numbers from it? And how are we going to disseminate those?
Yeah, I mean, obviously we have some numbers now from year 1. Year 2 will make it even better, and year 3 will make it even better than that. And so I think we're not going to come out with some real formal publications until we get that 3rd year done, so that we don't have to change them from one year to the next. We will be holding the Blue Creek field day. So the USU Blue Creek farm is located about, I don't know what that is, 2-3 miles from the Idaho state line. It's in Utah, but it really serves a lot of the Southeast Idaho growers. We will have the Blue Creek field day this coming year, and one of the locations is at that farm. So everyone's welcome to come and see it at that time. We'll have some handouts with the data from last year, and then they can kind of see this year's trials and how they look, and we can walk through them. So we'll be doing those kind of things and just getting it out through field days, through publications, through we'll do some YouTube videos and those kind of things, but that's kind of the plan from now.
All right, and if you send that information to me, Earl, I can make sure that we send it out through our channels as well, and kind of advertise that for you to get more people there.
Perfect, that'd be great.
Yeah,
Great.
absolutely. All right, well, just before we end, does anyone else have any questions? I don't want to cut questions off. Corey, did you have more that, or you're good? All right. Jim, are you, looks like he's good.
I'm good.
Okay. All right. Well, thank you so much, Earl and Grant and Brad, for joining us today. I will go ahead. This video will be posted to the Idaho Wheat YouTube and to the Idaho Wheat podcast platforms. So you can find those on our website later today or tomorrow. And then in that, I can include email addresses, contact information for Earl, Grant, and Brad if you have additional questions that you think of that you want answered. So thank you again so much for joining us. We will see you next month at our next From the Field, and we hope you have a really wonderful Thanksgiving.
Thanks.
You
Thanks
too.
so
Thanks for
much.
having us.